Hi guys, and welcome back to another video. So a few videos back I covered me setting up my QO-100 ground station again, as it had been out of action for a few months, and in that video I asked if any of you were interested in seeing a video on the absolute basics you'd need to start receiving QO-100. So in this video we're going to cover that. Now for those of you that do not know what QO-100 is, let me just quickly explain and then we're going to move on to how to receive it. So the first thing is that QO-100, now excuse my drawings, I'm not an artist here. Now QO-100, it's a geostationary satellite that's 30,000 to 40,000 kilometers above Africa somewhere in Middle Earth, and it's an amateur radio repeater essentially. It's actually piggybacked onto another satellite which is used for television broadcast, but QO-100 provides two transponders for amateur radio use. Now we'll talk about those transponders in a moment, but essentially what happens is it receives on 2.4 gigahertz and then it transmits back down to Earth on 10 gigahertz. Now what that means is that if you're a ground station, you know, you're in your shack here, you've got a little satellite dish, extremely small one I've got here, it means that you're going to need to transmit on 2.4 gigahertz and receive on 10 gigahertz. So essentially you transmit on 2.4, QO-100 receives 2.4 gigahertz, and then it retransmits your signal back down on 10 gigahertz, and then you have to receive it. Now QO-100 has two transponders. It has what we call a narrowband transponder, and it has a wideband transponder. The narrowband transponder has things like CW and SSB. There are some other modes on there like FT8 as well. And the wideband transponder is primarily for digital amateur television. In this video we're going to concentrate on narrowband, but we may touch on wideband DAT reception at the end because there's a new piece of software out which means you don't actually need any extra hardware, which is really good, and I've covered it on the channel before. So let's talk about this path here. How do we receive this 10 gigahertz signal? Okay, so let's look at the hardware that we're going to need. So the first thing we're going to need actually is something called an LNB. Now this particular model, it's a Bullseye LNB, and it was specifically made for use with QO-100 because it's ultra stable to 10 kilohertz, and it's quite important to have a stable LNB when you're receiving such high frequencies, especially if you're going to be using SSB, narrowband transmissions, because the slightest bit of movement in frequency can make somebody sound like Pinky and Perky, or they may sound like Barry White. So essentially what this LNB does, and it's the same with all LNBs, this is not special in any way in terms of it doesn't do something that another LNB doesn't do, apart from the fact that it's very stable. So it obviously these attach onto the arm of a satellite dish, and we'll go outside in a bit and I'll show you that. So essentially it receives the 10 gigahertz signal from QO-100. Now these have a low of 9 gigahertz and 750 megahertz. What that means is when you're receiving on 10 gigahertz into here, you're actually getting an IF output of around 739 megahertz. And the reason why that's important is because we don't really want to start processing the 10 gigahertz signals. We want to work with something a little bit more manageable, because there's only specialized equipment that would really work with 10 gigahertz natively. And for us home users, we just want to use simple, cheap SDR receivers, or even a homemade scanner or something. So what happens is we've got the LNB, so 10 gigahertz comes in, 739 megahertz comes out of this green port here. The red port here is a 25 megahertz output, which kind of tracks with the drift within the Bullseye LNB. But what I would suggest is just ignore that for now. We're going to concentrate on here, which is the green port. This is the output which will go to your radio receiver or SDR. However, there's one thing that we need to have between this and your receiver, and that's something like this. Now this is called a bias T. Now the bias T allows us to connect the LNB to something like this. Now this is just a cheap RTL-SDR receiver. So what happens is the RX goes to here. Now you may be wondering, why do we need this in between? Now there's a very good reason for that, and that's because this needs power. But obviously it doesn't have a separate power port. We have to supply the power through this green connector here. So we use this bias T and we put a DC voltage into it. Now there's two voltages that we need to think about here. So the first is 12 volts and the second is 18 volts. So 12 volts will make this LNB receive with a vertical polarization. 18 volts supplied will give us a horizontal polarization. Now if you remember earlier I said about the two transponders that we've got. So we've got the narrowband transponder and then we've got the wideband transponder. The narrowband is vertically polarized and the wideband is horizontally polarized. So if we're just looking at receiving SSB signals then off the narrowband transponder, then we need to supply 12 volts into here. Now that 12 volts will go into the DC port, out of the LNB port into here. The RF that comes down from the satellite will come out of here through the bias T out to our SDR receiver. The bias T will stop any DC going to this. That's the last thing you want because obviously you can damage this. Now the power supply that you use here can be something that you've made yourself. It can be a desk power supply. It can be pretty much anything as long as you can get 12 volts for the vertical polarization. Now there are other devices. You might have seen these kind of things around before. These are just standard commercial satellite dish connectors, but it's essentially the same thing. This thing here, it basically allows you to input a 12 volt DC input here, or 18 volts, and then that connects to your LNB, and then that connects to your receiver. So you might have seen these lying around as well. Essentially, these two things do the same thing. Now, if you wanted to make your own simple solution for the bias T, you could make something like I've made here. Now, what this will do, it will take a USB input, so I can just plug it into a normal USB connection. I can connect my LNB to this side, and then I can connect a SDR receiver or anything this side, and using this switch I can actually switch between 12 volt and 18 volts for powering the LNB. So if I just connect up the power, so that's 12 volts, and then flip the switch and that's 18 volts. So I can easily switch between horizontal and vertical just from inside my shack here. So inside, this is the actual bias Tee PCB. You can buy them extremely cheap off of Amazon or eBay. And then I've just got a single pole double throw switch here. That's a LED voltmeter, which is on the top. And then here we have just two kind of step up transformers. I've bought these connectors off of Amazon as well. It's just a USB-C, and you get two power leads that come out, a red and a black one. They just feed both of these at the same time, and then using these trim pots, these little blue things, you can actually then adjust the output voltage. So I've got one set to 12 volt, one set to 18 volt, and then through that switch determines how much power is going to the bias T board. And that's it. Pretty easy and pretty simple to set up, but it saves a complete headache in carrying big power supplies and batteries around if you're going to be taking things like this portable. It's a lot easier just to make something like this. You can do it very cheaply and relatively quickly as well. I don't think there's anything off the shelf you can buy, so making stuff like this is it's actually quite good fun. So I would recommend it if you are going to be playing around with the narrowband and the wideband transponder. Now, before heading outside to align the dish, connect the LNB, etc., you want to take a look at this website. I'll leave a link to this down in the video description. Now, this will help you know where to point your dish. Essentially, so you've got the map over here, and over here you've got a drop pin. So you can essentially just put the pin where you are. So let's say I'm down here somewhere in Monaco. So I'm going to go all the way down here, and I am going to be nice. So this is my location, right? So that's my location. I'm going to be here. What you then need to do is look at the information over here on the left. Now, this is quite important. So ground station location. So this is just giving you some information about where you've dropped that pin, essentially. But the information that you're going to be interested in will be these three here. So you've got azimuth, which is degrees, and you've got elevation, again in degrees, and you've also got LNB skew. Now, LNB skew is where you turn the LNB left or right in its holder. I'll show you that when we go outside. But the azimuth is essentially left and right in terms of degrees, and then you've got elevation, which is up and down. Now let's go outside and attach the LNB to the dish, and then we'll come back in and we'll connect everything up. Okay, so this is with the LNB attached to my dish now. Now, you can kind of ignore the cable that's being used there. Generally, you would use 75 ohm coax, but I don't actually have a 75 ohm coax feed going from here into my shack, so I'm just making use of some 50 ohm coax. The twisting part that I mentioned earlier, or skew, is essentially this part where you can kind of twist it like this, so we all need to make sure that it's correct. You can also adjust how much this is pushed in and out to get the perfect focal point as well towards the dish. So that's something else to think about. So in terms of alignment, you could use something like this on your mobile phone to give you a rough idea of which direction to point the dish. Once the dish is pointed in kind of the rough direction, you can then make sure that the elevation is set correct. Now, the elevation, there's normally a marking. This is the marking here on my dish, but your dish will also have a elevation setting as well, and that's what you need to kind of roughly set it to. So here we have the coax coming in from the LNB from outside. It's going into the output side of the homemade bias T-box, and obviously I've got it switched to 12 volts. And then on the other side, I've got an RTL-SDR. Now, I'm going to use the RTL-SDR to demonstrate narrowband, and then we'll switch to another SDR a bit later when we try some DATV on the wideband transponder. Now, there's a couple of software packages that I probably would recommend to use. The first one is SDR Plus Plus, and that's because it's multi-platform. It supports multiple operating systems. So whether you're using Linux, Raspberry Pi, Windows, you can still use this application. The other application, which I'll show you in a moment, will be SDR Console, but that only runs on Windows. However, it's very good. But let's take a look at SDR Plus Plus. So with SDR Plus Plus and your RTL-SDR connected and plugged into your computer, you can select the device on the top left. So I've got RTL-SDR selected as the source, and it's already detected my RTL-2832U OEM device. A couple of settings that we want to change is we want to make sure that RTL AGC is on, tuner AGC is on. If we come down to where it says offset mode, if you click on the little drop down, you'll see something that says QO-100 9750. Now that is what you need to select, because what we're able to do here, instead of tuning to the IF output of the LNB, which would be 739 megahertz, we can actually tune the frequency on the actual application to the 10 gigahertz frequency. So, and by enabling this offset of 9 gigahertz, 750 megahertz, it will put us in the ballpark area. Now, I did actually have to make some slight adjustments to mine, and you can actually save your own custom offset if you want to as well. Oh, and one other thing to do as well is, as you can see, I've got the band plan across the middle here. You can actually change that and add the band plan. There's an option on the band plan section to select QO-100. So if I'll press play, and this should now bring up what we are receiving. So let's just take a quick look to see what we can hear.
Shoulder, and that was the reason that you think she was going way too fast. But very interesting to hear a bit more of a history. I'm due to buy, well, not buy a book new, because I'm a cheapskate, but I'll probably buy a book second hand and have a read. She was talking a little bit about her history and why she got into motorbiking.
So the next application which I'm going to show you, and is my personally preferred application for receiving and transmitting to QO-100 is SDR Console. Now, it does only run on Windows, so you will need a Windows computer for this, but it works extremely well, and a lot of work has been put into it to make it compatible and easy to use with QO-100. There's actually a specific layout which you can choose, which will provide all these different panels of information for when using QO-100. As you can see, the band plan is also there as well. So first I'm going to select a radio. Now, if you don't have the radio selected, you will need to go into definitions. But once you've selected the dongle or the RTL-SDR or whichever receiver you're using, make sure that you've got a converter selected. Now, obviously, the LNB that I'm using has a low of 9750, so that's what I'm going to select. You can choose a bandwidth here as well. You don't really need to go too overboard with a bandwidth, but as soon as I press start, it should now show me what is coming down from QO-100. Now, one of the interesting features of SDR Console and the QO-100 feature is that it has a geostationary beacon lock. Now, up here on the top right window, we can see this center PSK transmission. Now, on the bottom waterfall, you can see it's not actually in the middle. This should be here. So if we go over to the top right window and we just select that transmission, you'll see it's now got two lines either side of it. And if we press the play button, it will then instantly lock and put everything in its place. So we've got the CW beacon right where it should be. We've got the PSK beacon where it should be. And then we've got another beacon right at the top, and we've got the high-speed data beacon. Now, you can actually use these beacons for aligning the dish as well. You can look at the peak level on one of the beacons and then move your dish until the peaks are to their maximum. Obviously, you will need to look at this at the same time as moving the dish. So if you're going to be doing this outside, then it might be an idea to take a laptop with you, and then you can run the software. I mean, you can do this on any SDR application, but with the offset feature, you're actually seeing the true 10 gigahertz signal frequency that's coming down from the satellite rather than the actual IF frequency out of the LNB. Okay, so let's take a listen then.
Yes, okay, Martin, G4FKK. Let's try and get somewhere roughly on, there we go. Right, good, yes, all copied. Yeah, the workshop's going quite well, Martin. I mean, it's habitable just about now. It's still lacking a milling machine, which I would like to get squeezed in there somehow. But I've got the IT rack working, so I've got internet down there. I've got a couple of rigs. I'm working on a feeder switch, so I can switch all my aerials between the workshop and the shack up here in the house. So, yeah, it's coming along, Martin. There's still a few relatively major things that need doing, but they're mainly cosmetic, to be honest.
So this is SDR Television from G4ELI, Simon Brown, who makes the SDR Console application as well. So this is a proof of concept that he'd been working extremely hard on to receive digital amateur television from QO-100. It works with a multitude of SDR receivers and also transmitters, so you can also use this application to transmit to QO-100 as well if you have the correct equipment. Now, if you do want a video on transmit specifically, let me know down in the comments and I will make that. But okay, so let's get this started. Pretty much the same as before. We need to select a device. Now, I already have the Airspy Mini already selected. Now, when it comes to the size of the dish that you need, larger the better for when it comes to digital amateur television. These signals are quite wide and you do need a very good reception for them to work. Now, I'm using a 1.2 meter offset dish. That's what you saw earlier in the video, but you may be able to get away with smaller dishes, but the only way to tell is really to try it. Now, when it comes to the narrowband transponder, I don't think I touched on this earlier, you can get away with probably 60 centimeter as the minimum size dish for receiving the narrowband transponder. Again, bigger the better. The bigger the satellite dish, the higher the gain's going to be. And that'll also be the same case for transmit as well. Anyway, guys, I hope you found this useful, and I hope I've answered all of your questions. If you are looking at starting to get into this, maybe start off with the basics. Get a 12-volt bias T, an LNB, a receiver, and a satellite dish. Of course, there's other ways of receiving the narrowband transponder. You can also use transverters, which will convert that 739 megahertz IF from the LNB down to something like 144 megahertz, so you could use a standard SSB radio for receiving and listening to. I know there's a few people out there that actually do that, but that's a little bit outside the scope of this video, as I wanted to keep it as basic as possible. Anyway, guys, thank you so much for watching. Please let me know your thoughts down in the comments below. If you've got any questions, feel free to ask them, but make sure to ask them in the comments. Do not email me, as I will most likely not reply. Anyway, thanks so much for watching. Take care of yourselves, and we'll see you in the next video.